Hi, I'm here with Chemistry Cat. You made lithium react with argon? Liar. Argon doesn't like to react with anything because it's a stable, noble gas. So today we are going to be learning about empirical formulas, and hopefully you've accessed your notes so that you can fill them in as we go through the video. An empirical formula shows the smallest whole number mole ratio of elements that are in a compound. So if we have this molecular compound here, C6H12O6, and we would like to write the empirical formula, we look at these subscripts. The 6, the 12, and the 6 are all divisible by 6. So we reduce this down, and it becomes C1, and you don't write the 1, it's understood, H2O. So this is the empirical formula. CH2O is the empirical formula of glucose. So the 6, the 12, and the 6 get reduced down to 1, to 2, to 1. And that is our mole ratio, 1 to 2 to 1. So if you'd like to pause the video for a moment and determine the empirical formulas of these next 3 molecular formula examples, go ahead and do so. Okay, so hopefully you're back and you have these answers right here. So the 5 and the 10 are divisible by 5. That reduces down to P1O2. And 2 and 6 are divisible by 2. That reduces down to a 1 and a 3. And the 2, the 2, and the 4 are all divisible by 2, which reduces to a 1, a 1, and a 2. So that's what an empirical formula is. Now we are going to need our calculator and a periodic table in order to do the next couple of examples. So in this example, we have a compound that contains 0.900 grams of calcium and 1.60 grams of chlorine. And notice that we are given 3 significant digits here and 3 significant digits here. So the first thing we're going to do is convert both of these into moles. So I've got 0.900 grams of calcium times, and we're converting to mole, so 1 goes with the mole when we're doing our molar conversions, divided by the atomic mass of calcium rounded to one place past the decimal. And from our periodic table, it is 40.1 grams calcium equals. So 9.00 times 1 divided by 40.1 grams gives us 0.0224 moles of calcium. And I want to keep 3 significant digits. Remember, this 0 is just a placeholder. So here's my answer. Now I need to do the same thing with the chlorine, the 1.60 grams of chlorine. 1.60 grams chlorine times 1 mole of chlorine divided by 35.5 grams of chlorine, which is the atomic mass rounded to one place past the decimal, equals 0.0451. It's very important that we maintain 3 significant digits. Okay, so here's our 2 answers. What we want to do now is determine which of these answers is the smallest. And it turns out that 0.0224 is smaller than 0.0451. And what we are going to want to do now is to divide both of these answers by the smallest answer. So I'm going to switch to a pen now. And I'm going to now divide by 0.0224, which comes out to be 1 calcium. And I'm going to take this number right here and divide by 0.0224. And that comes out to be a 2. So my empirical formula is going to be 1 calcium and 2 chlorines, and you want to write them exactly as you encounter them in the problem. The calcium comes before the chlorine, and that makes perfect sense because you always write the metal before you would write the nonmetal. And our empirical formula, CaCl2. And we're always going to come up with a whole number ratio. Occasionally, that will not happen, and I'm going to show you in the next example what to do about that. So here's our empirical formula. This is what we're after. CaCl2. So here's another example. Now we're given percentages in this case instead of grams. The question asks, what's the empirical formula of a compound that's composed of 66.0% calcium and 34.0% phosphorus? So here's a hint. In place of the percent sign, you're going to use grams. You're going to then follow exactly what we did in the last example, convert it to moles. Look at both answers, or sometimes there may be 3 or 4 different answers, because you might have 4 different elements. And you'll determine which answer is the smallest and divide all of the answers by the smallest, and then you'll get your whole number ratios. Except sometimes you don't. So let me show you what this is all about. So let's see. I need, there. Okay, so 66.0, instead of percent, I'll use gram, calcium, and I'm going to convert it to moles. So times 1 mole calcium divided by the atomic mass of calcium, which is 40.1 grams calcium, equals 1.65 mole calcium. So for the next part, I've got 34 instead of percent, use gram, E for phosphorus, times 1 mole phosphorus divided by 31.0 grams of phosphorus, and that 31 comes from the atomic mass on the periodic table, rounded to one place past the decimal, equals 1.10. Again, we want to maintain 3 significant digits. Mole phosphorus. So now that I have my 2 answers, which one is the smaller answer? Well, 1.10. So I'm going to take this and divide by 1.10, and that will give me 1.5. not a whole number. I'm going to come down here, and I always have to show my work. So I'm going to also divide by 1.10, which of course comes out to be 1. Now, I have to have whole number ratios, 1.5 and 1. 1.5 is smack dab in the middle between a 1 and a 2. I am not going to round it to 2. What I'm going to do is double this, and what I do to one answer, I must do to all of the other answers. So I am going to now multiply by 2, which gives me 3. This tells me I'm going to have 3 calcium atoms. I also have to multiply a 1 by a 2. I need to double it as well, just like I did in the top example. 1 times 2 is 2. That tells me I've got 2 phosphorus atoms. Now I can put together my empirical formula. So my empirical formula is Ca3P2. Okay, and these would be subscripts that you could, oops, make smaller, like so. There we go. So this is my empirical formula, and this is what I was after. Ah, isn't that nice? Here's my empirical formula. So you have a worksheet to do, and don't forget to show all of your work and to submit it before the due date, which is Monday, 7 a.m. If you need help, stop into my office hours from 10 to 11 and 1 to 2 Monday through Friday.